record. All right. Let me come here. So I'm looking in the Stevens Think Do book, and I'm looking at page 6, I think it is. And here's the definitions of random sample versus simple random sample. Now, a random sample says, as you see, it says, every member has an equal chance of being selected. Okay. The simple random sample says all possible samples. Now, do they say that? Did he say it that way? Every sample of the same size has the same chance of being selected. So the random sample means every individual. Simple random sample means we can get all the samples are possible. So I mean, what does that mean? Well, I got some data here. So this is a data I made for another class at another time, and it's about cars. Let's see what it is. It's about cars and I've got some continuous quantitative variables, and I've got some categorical variables. Well, so what if I want to pick, well, I know there's only 32 cars or 31 cars here, so it's not a very big population to choose from. But what if I wanted to pick 4 cars and measure their weight? Okay, so could do well, one way to do it. Well, actually, no, the first thing I got to do is I probably should do this. Let's assign each of these cars a number. No, these aren't the cars. These are something else here. Let me close this. This is another data list. Is this it? Nope, that's somebody else's. Here we go. Here we go. So, what I'm going to do is here, I'm going to get rid of that stuff, and then I'm going to number each of these cars, and I could go down to do 1, 2, 3, 4. I'm going to come on, Dan. What are you doing? I'm going to be lazy and let it build a formula. You don't worry about, if you don't know what I'm doing, don't do it. Don't worry about it. Okay. All I'm doing is I'm giving everybody a number. I'm giving every car a number. Now I want to pick 4 cars, so I need. I mean, I could just go through. Since I'm doing this video, let's do it all. I could just go through and randomly pick 4 cars. I could shut my eyes, let my mouse fall into one. Let's see. So I'm going to pick the Buick Skylark. They get so that weighs 25. 2,595 pounds. Okay, then I shut my eyes, let the mouse go again, and et cetera, et cetera, et cetera. Now that seems random, but really what it is, it's a convenience sample, right? Because I'm just letting honestly, I was letting my mouse go down, so I've got that movement that's biasing the thing, biasing my selection. So convenient sample, not random, not much good for other than what the numbers we get. Okay. To get a random sample, a simple random sample, you number every individual in your population or in your sampling frame. In this case, I've only got 31 individuals or 30 individuals. So that's my sampling frame. And I'm going to pick 4 of them. Now, how do I know what 4 to pick? Well, you get a random number generator, and a great one is random.org. Random.org. See, I've been going there a bit. And I'm okay with cookies. I'm gonna go to numbers, integers. Actually, let's go integer sets, because integer sets I can select numbers that are not repeating. So let's say I said I want to pick 4. So I'm gonna get 4 numbers. No, I want 1 set with 4 numbers. I know it's a very small sample. And each integer, what did I have? 130, I had 30 cars. So there's 1 to 30. And let's see, numbers set sequentially, because I'm only getting 1. Sort the numbers. No, doesn't this say no repeats? I wonder if I don't want to do another one, a different thing. Let's see what happens. Let me get set and see what happens. Are there repeats? Well, I didn't get a repeat, so I'm good. So here's my random sample. See, if you get a repeat, you don't want to sample the same individual twice. So if you get a repeat, you got to get another random number. So 7, 17, 22, and 28. So 7, let's see, where's my list here? Here's number 7. I'm going to sample that Chevette. I never really liked Chevettes. My wife had one. And what's the next one? What? 17, before I knew her. Saab. Do they even make Saabs anymore? 22 and 28. As you can see, I have memory issues. 22, 22. It's scary. 22 and 28. So those are the individuals that I'm going to pick in the sample. And this is truly a simple random sample because let's see, let me get my 28 because I picked those cars. Now I could just as easily gone back to random.org. Let me get 4 more cars. Okay, no repeats. I could go pick them. Notice 7 got selected again. So that's possible. And I could see, if I did this enough times, I could get every single sample of 4 cars possible. There's a lot of them. We won't go into how you would calculate that because I don't want to confuse the issue. But this is gonna, what I'm doing is doing a simple random sample. Now, what if instead of a simple random sample, I thought, well, maybe I should do a weights, our automatic transmission cars with automatic transmissions heavier than manual transmissions? I don't know. Let's see on average. Let's select a sample and see. So here, let me undo all my nice colorations. So in this case, what I would do, let's say I still wanted 4 individuals, 4 cars. So I'm going to pick 2 out of the, I'm going to pick 2 out of the automatic cars and I'm going to pick 2 out of the manual cars. And I could go do that. I could go, I could number it, not a lot of ways to pick that. But you see what's happening with that is I couldn't get not every individual, um, and I couldn't get, well, every individual has a chance of being selected. However, I couldn't get all possible samples. I couldn't get a sample of 4 automatic cars because I'm making it not be possible to get all automatics or all manuals. I want to spread it out and get some of each because I want to make my sample representative of my population. See, it's not a bad thing not to have a simple random sample if you because what you want is you want to have your sample represent your population. This is what happened in the 2020 election when you probably read about this. And if you didn't, this is good because the exit polls had Biden sweeping the country. Okay, and what happened? We know it was so darn close. And what happened is the only people. So their sample was people coming out of the polling places saying who'd you vote for, blah blah blah. Biden people by far spoke up and let that be known. Trump supporters tended not to respond. I'm not saying they didn't respond, but they tended not to. Okay. So what they were suffering from was a non-response bias. So they had their sample wasn't representative of the population. Okay. So you want to have your sample represent the population. Otherwise, your sample is not very good. So simple random samples they're the gold standard. They are not, sometimes they're not what we want. Okay. It's not a bad thing to not be a simple random sample. It's just that that's the gold standard and we'd like to have them if we can. Okay. We can get good data if we don't, but that's the difference. Did I answer your question? What's the difference between a random sample and a simple random sample? The simple random samples are all the possible samples are equally likely to be drawn, and the random sample is just every individual has the same chance of being drawn. Don't sweat this. This is the little thing. I want you to understand what a convenience sample is, a voluntary response sample. I want you to be able to recognize those. Everything else, most of the other sampling techniques we do are fine. Okay, you'll see systematic, this cluster. Those are all good. They aren't all simple random samples, but they're still great samples. The voluntary response and the convenience samples. Don't. I want you to be able to recognize that those are garbage. Okay, we don't want them. All you can do is that's like a straw poll, right? Straw polls only tell you about the people that responded. Okay. Hopefully this helps, and don't hesitate to give another yell if you need it.